We can also use trigonometry to find missing angles in right triangles. Typically when you set up one of these equations, you're going to see something that looks like this, where your angle is what's unknown. So if you don't know the angle, use an inverse trig function to solve for that. So these two are really just calculator problems to get us used to how the calculator is going to work before we get to an actual problem. Again, because we're missing the angle, we're doing a new kind of trigonometry called inverse trig. You'll see it on your calculators as a trig, or a sine, cosine, tangent with a little -1 looking exponent with it. We call those inverse trig functions. To get them, or to access them on your calculators, typically just press second sine or second cosine. So this is what you should see displayed when you type in second cosine. Make sure, as always, you're in degree mode for what we're doing right now. When you do the inverse cosine of 0.87, we get an answer of about 60. And remember, we're finding a missing angle, so let's use a degree symbol with that. I rounded to the nearest whole number because it said in the directions to round to the nearest degree. Same thing over here. I want to find that missing angle. I don't know what b is, so I'm trying to find the angle that gets me a cosine of 0.15. So, oops, I don't know why I'm rewriting the problem, but whatever. So again, since I'm missing the angle, I'm going to do an inverse cosine this time. So cosine, it looks like cosine to the negative first. And then just use a calculator to find the angle that's missing and get about 81 degrees. So that's relatively easy, just a simple calculator kind of computation we're doing. Let's go ahead and take a look at how we're going to use this to actually find a missing angle in a right triangle. So let's do that same setup, that same process, but the first step is going to be, just like if we're finding a missing angle or missing side, figure out what trig function we need to use. So in this case, we're asked to find angle A. So I'm going to circle angle A right here. And then, as before, identify the sides I have to work with to help me figure out whether I'm doing sine, cosine, or tangent. So I'm asked to find angle A. I know that this side right here is the hypotenuse, the side across from the right angle. The side here that's right next to the angle is the adjacent side. The opposite side is down here, although it's not labeled. There's nothing I want to know about that right now, so I'm pretty much just going to ignore that side. So it looks like I'm working with adjacent and hypotenuse, so going back to what you remember about SOHCAHTOA, the part of SOHCAHTOA that uses H and A must be the ka part. What that's telling me is I'm going to be doing the cosine this time. So I'm going to say cosine of the angle. This time I don't know the angle, so I'm going to do cosine A, it's unknown, and then equal to the adjacent side, which is 6, over the hypotenuse, which is 11. So we get a problem that looks very similar to what we saw on that previous screen. So at this point, I'm finding the angle. If you're finding an angle, do an inverse. So I'm going to do the inverse cosine, that's second cosine or cosine to the negative first. Use parentheses on your calculator, and you can just type in 6 over 11 or 6 divided by 11. If you want to make 6 divided by 11 a decimal, you can certainly do that. But if you're careful with getting this typed in with those parentheses, you should get an angle of about 56 point, well, let's see, it says to round to the 10th this place. So 56.9 degrees. And remember, it's an angle, so use a degree symbol with that. If you think you've got it, why don't you go ahead and try this one. You can pause the video and try this one on your own. It's the same thing we just did. Otherwise, in just a couple seconds, I'll have my work pop up if you want to check your work or just kind of see what I did. There you go, an angle of about 36.9 degrees. Hopefully you got that as well. Otherwise, make a note, ask me a question in class, and we can take a look at it. Otherwise, there's just one last thing I want to show you with these problems, and that's the story problem. Remember, even though there's words with it, it's really probably no different than what we just did. So in this case, we want to build a ramp to, it looks like a hospital, I suppose. We want to make sure that ramp's not too steep, otherwise, well, you can guess what's going to happen if the ramp is too steep with wheelchairs. So let's go ahead and figure out what the angle needs to be for this ramp to make sure it meets the regulations. So I'm going to draw my right triangle to help me visualize what's going on. It says the wheelchair ramp must rise 8 feet. So I'll put an 8 over here on the rise for every 20 feet in length. I'm going to consider the horizontal part, the 20 feet in length. And then we want to know what the angle is. Remember, anytime you're asked to find an angle, do an inverse. So I'll put a little theta right there, or an x, or whatever you want to use to represent your angle. So again, as before, you can see it's really no different than what we've just been doing. Let's figure out what our two sides are called based on this angle right here. Looks like once again we've got the opposite and the adjacent. We know from that last example we're using tangent this time. Tangent's the TOA part, which uses opposite and adjacent. So I'm going to write tangent of theta or x, whatever you want to use, equals the opposite side 8 over the adjacent side 20. Again, since I'm missing that angle, I'm going to be doing an inverse to solve for this. So the inverse tangent of 8 over 20, or 8 divided by 20, gets me an angle of approximately 21.8 degrees. So I want to make sure my ramp, 21.8 degrees, there you can see it better, 21.8 degrees. I want to make sure my ramp is no steeper than that.